All right, we're going to work on 5.1. You'll have to let me know if this recording is much better than the other one or how this one goes. All right, so we're going to start with number 17. And the function they give us is f of x equals 4x plus x cubed. Okay, and they want us to know, at least for this problem and the next one, is it a polynomial function? Yes or no? Okay, so we're just looking at the function itself, and we want to know, is it a function, yes or no? So the best way to determine this is if I see the function and it looks like a function that I've probably seen before, it's likely that it's a polynomial function. So this looks like a standard function that we could factor, all of those good things. Nothing strange is going on. So this one is a function, yes. And then it asks for, if it's a polynomial function, what is its degree? Okay, so the degree that we're looking for is, if there's multiple terms, you're going to look at the one with the biggest exponent. So on this one, we're dealing with x cubed, and you take the exponent then. So the degree is 3. If there were more than one exponent, and it was, for instance, like an x squared y cubed, so your term had multiple terms, or not multiple terms, sorry, multiple variables, you would take the exponents and add them together to get 5. Okay, I don't believe that this happens in our text, but if it does, then you at least have an example of it. Okay, so the other example we have is 21. And f of x equals 1 minus 1 over x. Okay, so this one looks like something we've seen before, but again, think, could I factor it? I can't factor it. Okay, it has x on the bottom. So that means that it's not a polynomial function. Okay, so if it's not a polynomial function, the MyMathLab is going to ask for a reason. Now, I don't know if it's a drop-down box or what it does, but the easiest way to describe this one is if we were to rewrite 1 over x with a negative exponent. So you can write 1 minus, this is also x to the negative 1. So the easiest way to tell you is, hey, it's not a polynomial function because we have a negative exponent. Not a negative degree, but a negative exponent. Okay, so that's what's important here. It's a negative exponent or a negative power of x, I think is how the MyMathLab describes it. We have a negative power of x. Okay, so for the ones that are not a polynomial function, you're going to see x in the denominator. You're going to see x with a fractional exponent. Okay, so that one looks like x to the 1/2 or something similar with that. Or you're going to see x with a negative exponent. So those all look like things that we wouldn't necessarily factor. So like x to the -3, something of that sort. Okay, those are all things that are going to cause us not to work with it. All right. The next thing that we deal with in 5.1, again, to set up the chapter, is this chapter we're really going to focus on polynomials that are sometimes to the 4th and 5th powers. So in 35, they're going to ask us f of x equals negative x to the 5th, and we're going to graph it. Okay, so my guess is on MyMathLab it's going to be multiple choice. On the classwork, I ask you to actually graph some of these, And we're going to use some of those things that we learned back in chapter 3 to remind ourselves what it actually does. So this takes y equals x to the 5th and reflects it across the y-axis. Okay. The other way that I deal with this one is put it in the calculator. So let's put it in the calculator. All right. So y equals negative x to the 5th. Okay. But the hard part here is it shows in everything. Here's my negative 10 to 10 box. Okay. So when I go to the table to look at the graphs, because we're dealing with a cubic number, I'd rather get something that looks very close, or sorry, that gets close. So I have 0, 0. I have 1, negative 1, and I would also like to include 2, negative 32. Yes, it's really far off the graph, but it does give us a much better idea of where the graph goes. So we're going to include 5 points again. So I'm going to use x, y, negative 2, negative 1, 0, 1, and 2. And I get negative 32, negative 1, 0, negative 1, and negative 32. Again, just pull it off your table on the graph. Okay, and I went by, I don't know, let's go by 4s. So negative 4, negative 8, negative 12, negative 16, negative 20, 24, 28, and 32. So I have 1, so I should have 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going way up there. I only have 1, 2, 1, 2. So I get 0, 0, and 1, negative 1, 2, negative 32, and I get negative 1. That maybe I did something wrong. Hold on. 1, negative 1. No, 2, negative 2. Negative 1. 1, I think. Let me double check. Yeah, I wrote that down wrong. This is a positive 1 and a positive 32. All right. So it goes like this, and I drew it off, of course, and it goes like this. So it's a cubic function. Close enough, I put all the points on there. Okay, so nothing too far from what we had other than it's a really big numbers here. Okay, so on this next function, or sorry, this next problem, it asks me to form a polynomial function whose real zeros and degrees are given. They give us the following zeros: negative 1, 1, and 3, and the degree is 3. Okay, so again, here's the word function. We need to write f of x right away. Okay, so the zeros, remember when I get zeros, I get something that is set equal. So I would have gotten, let's put it in the margin over here, x equals negative 1. So if I get x equals negative 1, to write it as a factor, I get x plus 1. So when I write it in a parentheses, I'm going to write it as the opposite. So this middle one becomes x minus 1, and the last one becomes x minus 3. And the degree means that there are 3 parentheses. So I have 1, 2, 3. Okay, and this is for a equals 1. So if I had an a right here, it's going to equal 1. I'm not going to give you something where a isn't equal to 1. That makes it really hard. All right, and then my math lab is going to ask you to multiply this out. So I'm going to start with these two. And so it's the difference of two squares. So I get x squared minus 1 times x minus 3. So you want to multiply two of them first and ignore the third one. And then now I'm going to FOIL it. So I get 3x squared. Oops, sorry. Let me do it first. That was still outside term. I get x cubed minus 3x squared minus 1x or x plus 3. So that's the answer on that one. All right. So on the next problem, they give us a function like we just finished with. So we get 3x minus 7, x plus 3 squared. And this is one of our favorite multi-part problems. Okay, we're going to list each real zero and its multiplicity. Okay, so each real zero is going to be what comes out of these two parentheses. So here's one, here's the other. You set them equal to 0. Okay, so x minus 7 equals 0. So x equals 7. That's its 0. And then the multiplicity is the exponent. So its multiplicity is 1. And that'll become important in a minute. We'll talk about it. And the other one is x plus 3 equals 0. So we get x equals negative 3. And its multiplicity is 2 because, again, the exponent is 2. All right. So the next part asks, determine whether the graph crosses or touches at each x-intercept. Okay, so we can determine it by the multiplicity. So odd multiplicity means that it's going to cross, and even multiplicity means that it's going to touch. And you can verify this by typing it into the calculator. So I'm going to type in our function into the calculator. So I'm going to get 3x minus 7, x plus 3 squared. And so again, we can look at these pieces. So at negative 3, it touches, and at 7, it crosses. So if you can remember, it makes things go a little faster, but you can type it in. Okay, C asks for the maximum number of turning points. All right, so the maximum number of turning points always happens from its degree. So it's going to be its degree minus 1. Well, I really think that this becomes much clearer when we look at D. So let me look at D and we'll come back to C. So D asks us to determine the end behavior. Okay. So what we're going to do to determine the end behavior, we're going to take the original function, so right here, and we're going to drop off the zeros. So we're going to drop off the negative 7, and we're going to drop off the plus 3, and we're going to then simplify it. So it's going to look like this. F of x equals 3. The first parenthesis becomes x, and the second one becomes x squared. okay? And then you're gonna simplify. You get 3x cubed. So the graph, when we graphed it, should have looked like a cubic graph. So let me take my graph that I had on my graph here, and I'm going to expand it out for you. So I'm going to go by 30 and 3s and see what happens. It might not be enough, but we'll find out. Nope, not quite enough. So let me widen out my y range. That's the one that's causing problems. So we're going to go negative 100, 100, and go by tons. And it got much closer, but you still can't tell. Let me widen out a little more. And it still didn't quite get there, but hopefully you saw when it was drawing the actual graph that it was doing a cubic nature. So it definitely is a cube. It's going up and then back down, okay? So the end behavior is a 3x cubed. And it's much easier if we look at 3x cubed to then determine its degree. So I don't have to read between the lines. Well, the degree is definitely 3. So 3 minus 1 gives me 2. There's 2 turning points as a maximum. Okay, and we'll reinforce that here in a minute when we do another problem. Okay, so let's look at one where they give us the graph. So let's draw the graph out. I have 1, 2, 1, 2, 1, 2, 1, 2. I'm going to go up this way through the middle and back up. Okay. So the first thing we want to do is to determine if it's a polynomial function. So we need to go back to way before spring break to the vertical line test. So that probably was in chapter 4, but it's been quite a while, so I don't quite remember. So if it passes the vertical line test, doesn't hit more than 1 point, it doesn't do that, so it's a polynomial function, yes. If that happens, we need to find the real zeros. And obviously on my math lab, it's going to be much more accurate. On your classwork, it's going to be much more accurate. But it should go through negative 1, 1, and 2. Okay. And then the last thing it asks you for is the least degree. Okay. So the smallest degree this one could be is 3 because it has 3 real zeros. So we could have created a function that's x plus 1, x minus 1, x minus 2 if we wanted to. So it would be a cubic function. So that's the smallest it could be. It could be bigger because it could have some imaginary zeros, but for what we know, it's just x plus 1, x minus 1, x minus 2. All right. In the last problem, we're going to try and put a lot of this together. All right. So we get the formula or the function x squared x minus 3. And the first thing it asks is for you to determine the end behavior. Okay. So again, drop the negative 3. So we're going to get y equals x squared times x, which is x cubed. So the end behavior is x cubed. B is going to ask for the x and y intercepts. Okay, so for the x intercepts, we're going to set it equal to 0. And then find the 2 x-intercepts here because there's only 2. So for the x-intercept, we're going to get 0, 0, and we're going to get 3, 0. For the y-intercept, you're going to make x equals 0. So we get 0 times -3, which is 0. So the y-intercept is also 0, 0. All right. C asks for you to determine zeros and their multiplicity. Okay. So the zeros are actually the same as the x-intercepts, just the x values though. So we have 0 and we have 3. Okay. And 0's multiplicity is 2 and 3's multiplicity is 1. And it's also going to ask you, does it touch or cross? So again, if it's an even multiplicity, it's going to touch. And if it's an odd, it crosses. And you can double check that with your calculator. D is going to ask you to graph it with your calculator. My guess again is that you're going to match that one. Okay. A few things that you could already put on your graph though is that it goes through 0, 0, it goes through 3, 0. But other than that, you're kind of taking a look at the graph. So I'm going to type it in. So I get x squared, x minus 3. There's my x squared, x minus 3. I did change my window, so I'm going to do a zoom 6 to recenter it. And it's not going to be super accurate. I didn't make any Y lines, so I'm just going to kind of just somewhat sketch it. And there we go. So that's what my graph looks like. E is going to ask us to approximate the turning points. All right, so to approximate the turning points, here's my graph again. I'm going to look at the one on the left first, and I'm going to do a second and a calc. And I'm going to do number 4 for maximum. And right now it's highlighting pretty much right where it is. So again, I need a left bound on the left side, and I need a right bound on the right side. And again, hit enter through guess. And notice it gives me these weird numbers that say E -7 and E -12. So those are those numbers times E to the -7. So it's like, I can't quite read the number. It's -6.7 times 10 to the -7. So it's -0.000000067. So it's super small. So these two numbers are actually representative of 0, 0. So one turning point is 0, 0. The other turning point is a minimum. So second calc, number 3 for minimum. I'm going to go to the left side and to the right side. The third one's a guess, so I'm going to hit enter. And it's going to ask us to round if it's not super accurate. So this one is to -4. So do be careful if it asks you to round on the ones that you're doing. Okay. I have it written down as round to the nearest integer. So just double check me on MyMathLab. Okay. F says use the info to draw the graphs by hand. So I could have made this graph go to -4, so I could have made that go down a little bit further. I'm going to slide G in over here. G is going to ask for domain and range. Okay. If you can remember back to way before the break, domain and range for these ones are all real numbers. So a cubic graph is all real numbers. And then I'm going to squeeze H in down here. we need increasing and decreasing. Okay, so increasing, we're going from negative infinity to 0. Remember, we're only using the x values. We're going 0 to 2. Remember, this is 2, -4 at that turning point. So 0 to 2. And then it's going 2 to infinity. We don't need any union symbol. They're all parentheses. You can put a comma here. My guess is on my math lab, you need a comma. So that's all you need there. Number 81 is kind of, again, the one where we're going to combine everything that this lesson put together, other than 69 and 45, I think was the other one. 43. That's kind of the other half of the lesson. So if you have any questions, email me, ask at the beginning of class on Wednesday. Otherwise, this is kind of the set for chapter 5. So that's it.